Hey guys, today we're going to talk about probability. Okay, so just a review from last week, the probability of an event occurring would be the number of favorable outcomes, so whatever we're looking for, over the number of possible outcomes, kind of like your total. Okay, when we talk about probability, you can have your answer written as a ratio, meaning a fraction, a decimal, or a percentage. Okay. When we look at those numbers, if they're written as decimals, what we kind of talk about is it's on a scale of 0 to 1. 1 means it's absolutely going to happen or 100% going to happen, okay? And then 0 means that it's absolutely impossible, okay? So impossible would probably be like, if I think about a dice has the numbers 1 through 6 on it. So I would ask you something like, what is the probability of rolling a 7 on your die? And you would say 0 because there's no 7 on there. Okay, something that's close to 0.5 means it's equally likely to occur and not occur. That would be like flipping heads or tails on a coin. We usually say that theoretically it's about a 50-50 chance. Okay, so it says, what is the probability of rolling numbers that add to 7 when rolling 2 standard number cubes? Now, they talk about a standard number cube, and that's really just your dice. So like we said, those numbers 1 through 6. If I look at this table right here, what they've done is they've given me the outcomes of 1 through 6 on one side, and then 1 through 6 on this column right here, and then they're showing me the combinations that are possible. Okay, what we've done is we've put circles around all of those combinations that would add up to 7. Okay, so that add to 7. So how many outcomes are there? It's 1, 2, 3, 4, 5, 6 out of a total. How many outcomes do you think are on that table? You could go through and count them, or you could really just think like 6 times 6. So there's 36 total. Okay, when we calculate, we're going to go a fraction. We're also going to go a decimal. And I would like you to do your decimals to 3 places. So if I go 6 divided by 36, I end up with 1.66667. So I'm going to say it's approximately 0.16. I'll round that last decimal up to 7. And that's how I would like you to express your answer. So it says your turn. What is the probability of getting the sum, each sum, when rolling as 2 standard number cubes? So sum means that we are adding the 2 values together. So numbers that'll add to 9 is the first one. So if I kind of look on my table, I know like 3 and 6 add to 9. So that would be 1, 4 and 5, and then I could have a combination of 5 and 4 and also 6 and 3. So how many outcomes is that? 1, 2, 3, 4. So 4 out of a possible 36, and if I want to calculate that, 4 out of 36 is approximately 0.111. Okay, next one, what's the probability of getting a 2? Well, when I look at my chart, the only way to get 2, a sum of 2, would be 1 plus 1. So that would be 1 outcome out of 36. And if I calculate 1 divided by 36, I end up with 0.028. The last one says, what is the sum of getting a 13? Well, when I look at my chart, my largest number is 6 and 6. And if I add 6 and 6 together, this equals 12. So is it possible to get 13? No. So it would really be 0 out of 36, or I could really say 0. It's absolutely not going to happen. It's not possible. Okay. Looking at this next chart, it's called a frequency table. You do not necessarily need to add this to your notes. A frequency table, it says it's a data display that shows how often an item appears in a category. So how often, how frequently something happens. It says this frequency table shows the number of each donor type at a school blood drive. What is the probability of randomly selecting someone who has type A blood? Okay, remember when we calculate our probability, we say it's the favorable over the possible or the total. Okay, so the favorable meaning I'm looking for people that are donating type A blood. And how many people donated type A? Well, it says 25 of the people that donated were type A. And then I need to know the total. So what I'm going to do is I'm going to add 30 plus 25 plus 6 plus 2. 30 and 25 gives me 55, plus 6 would give me 61, plus 2 more would give me 63. Okay, so 25 out of 63. And then I can plug it in my calculator and I can say 25 divided by 63. It's going to be approximately, I got 0.3968, so I'm going to round it to 0.397 is what I'm going to say. Okay. All right, we're going to talk about two different types of events, and the first one is going to be an independent event. It says an independent event, the occurrence of an event does not affect how another one occurs. Okay, so two things can happen and they're not going to influence each other. This could be something like I flip a coin and I spin a number on a spinner. Those are two separate events and one does not affect the outcome of the other. Okay, dependent events says that the occurrence of an event does affect how another one occurs. Okay, this would be something like if I had 6 marbles in a bag and they were all different colors, and I asked you, well, what's the probability of drawing a red marble out of that bag? And I just select one, so my probability would be 1 out of 6. But then I say, keep that marble out. And what's the probability of drawing a red marble this time? And now it's a dependent event because once I took a marble out of the bag, it's going to affect the probability of the next time I draw a marble. Okay, we're going to look at some ideas here, and you're going to tell me if you think they're independent or dependent. So the first one says, I choose a number tile from 12 tiles, and then I spin a spinner. What would you guess? Is this going to be independent? It doesn't affect one another, or dependent? They do affect each other. This one is actually what we would call independent. They don't influence each other. Next one says, I pick one card from a set of 15 sequentially numbered cards. So basically they're saying cards numbered 1 through 15. Then, without replacing the card, I pick another one. Now, since I've taken a card out of the deck, what that means is I've affected the probability of the second chance. So that would be dependent. Okay, just some practice with these independent and dependent. All right, this one says, the amount of practice and the race times in a marathon. What do you think? I would say this is dependent. Usually if you practice, your times will improve. What about hair color and GPA? I would say this is independent. I could have any color hair and have the same GPA as my neighbor. Color of the car you drive and your GPA. Once again, I would say these are independent events. A person's height and their shoe size. Now, this could be argued either way, but I would say more than likely this is going to be dependent. Usually, the taller you are, the bigger shoe size you have. Miles driven and the fuel left in your fuel tank, that's going to be dependent. Okay, all right, moving on. Compound probability is going to be a big focus for today. So compound probability, it says it's the likelihood of 2 or more events occurring. Okay, so like an example would be the probability that it rains and I eat pizza. 2 things that are going to happen. Okay, what's the probability that I roll a 6 or I roll a 5? I'm looking for one or the other to occur, but I'm looking at 2 events. Okay, so there's a rule here, and if I want to find the probability of A and B, now that special word and right there, if I want to find the probability of A and B, then I need to find the probability of event A and multiply that times the probability of event B occurring. Okay, so anytime it says and, I need to multiply. If I want to calculate the probability of A or B, okay, or means I'm going to add. So probability of A or B occurring, I'm going to take the probability of event A and I'm going to add it to the probability of event B. Probably sounds a little bit crazy or abstract right now, but we will do some examples and I think you'll catch on. Okay, so this one right here, coming back to that frequency table, it says find each probability. What's the probability that I randomly select a student with type O or type AB blood? Okay, so first I need to figure out what's the probability that I select somebody with type O blood. Well, when I look at my chart, it shows me that there's 30 students out of a possible, do you remember this chart? It was out of 63. So 30 out of 63. Then it says, or I select somebody with type AB blood. Or means that we need to add the 2. Type AB blood looks like there's 2 out of 63. Now when I add fractions, I need a common denominator, which these two have the same denominator, so I know the number on the bottom is going to be 63. The numerators I just add together. So 30 plus 2 gives me 32. And now I can just type it into my calculator, and I say 32 divided by 63, and I end up with approximately 0.50, comes out to 5079, so I'm going to say 508. Okay, the next one says, what's the probability that I randomly select 2 students with replacement, that I select somebody with type O and somebody with type B blood? Okay, type O blood we did above, and it's 30 out of 63. What does this and mean? And means I need to multiply. Okay, type B blood. How many people have type B? Looks like 6 out of 63. Now, when I multiply fractions, I actually multiply straight across, meaning the numerator times the numerator. So I'm taking 30 times 6, and I end up with 180, and then 63 times 63, I end up with 3,969. Now, I don't necessarily have to show this step right here. I could just type both fractions into my calculator and multiply them. Okay, but if I type in 180 out of 3,969, I end up with 0.045, and that would be my probability. Okay, so here's some practice problems. It says, you have a spinner and a standard number cube. Find each probability. So the first one is the spinner is going to be over here on the right. The standard number cube, remember that's your dice, your numbers 1 through 6. Okay, so what's the probability that I spin a 2? How many 2s are on this spinner? Well, just 1 2, so 1 out of possible 6. This says and. What does and mean? Do I multiply or do I add? I need to multiply. I roll a 5. How many 5s are on my standard number cube? Well, there's 1 out of 6, okay? Remember, when I multiply, I go straight across, so 1 times 1 gives me 1. 6 times 6 gives me 36, and a probability for 1 out of 36 is going to give me 0.028, okay? Next one, what's the probability that I spin an even number? Okay, how many are evens on here? Well, the 2, the 4, and the 6. So how many outcomes is that? That would be 3 out of 6. It says and means I need to multiply. And then I roll a 2. Well, how many 2s are on my standard number cube? 1 out of 6. Okay, when I multiply, 3 times 1 gives me 3. 6 times 6 gives me 36. And when I go 3 out of 36, I end up with 0.083. Okay, last one. Oh, looks like there's maybe 2. Probability that I spin a 1 and roll a 5 or a 6. Interesting, it's got both there. Okay, probability that I spin a 1, well, that's going to be this one right here. So 1 out of 6, and means I multiply. What's the probability that I roll a 5? Well, that would be 1/6 plus a 6, 1/6. So what is my outcome here? Here I would get 2/6. Okay, when I multiply straight across, 1 times 2 gives me 2, 6 times 6 gives me 36, and if I go 2 out of 36, I end up with 0.0, it comes out 55555, so 0.5056 is what I'm going to round it to. Okay, the last example down here, what's the probability that I spin a number that's less than 5 and I roll a number less than 1? So if I look up at my spinner, it says numbers that are less than 5. Okay, so when I look at this spinner here, okay, how many numbers are less than 5? Well, the numbers that are less than 5 would be 4, the 3, the 2, and the 1. So how many outcomes is that? Looks like it's 4 out of a possible 6. It says and, I'm going to multiply. I roll a number less than 1. Okay, numbers that are less than 1 on that standard number cube. Can I have a number less than 1? It would be 0. That doesn't exist, so that would be 0 out of 6. When I multiply anything times 0, it's really 0. Since this second event cannot occur, that means that the combination of the two or together cannot occur. Okay, that is all for today. So we're actually going to skip the closing problems, and your assignment is going to be Unit 12 Day 1 worksheet. Thanks for tuning in, guys. Bye.